Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from group 6. Consists of me, Zulaika, Muhammad Azim, Ahmad, Zulhadi and Alia Aqila. Will be presenting our assignment that has been assigned to us, which consists of question 2 and question 4. Okay, for question 2, it's come from the article in silico modeling and simulation of magnetic nanoparticles for the biological cell isolation technique. For the introduction, magnetic nanoparticles are a group of nanoparticles that consist of magnetic elements such as iron, nickel, cobalt and their chemical compounds. Magnetic nanoparticles are widely used in a variety of applications such as magnetic resonance, imaging, MRI, biomedicine, and catalysts. The attraction between external magnetic field and the magnetic nanoparticles facilitates separation of a wide variety of biological materials, especially for the isolation of the wandering cancer cell from the body. So the idea behind this article is to isolate and remove leukemia affected cell from the system. So as we know, leukemia is a type of cancer with the abnormal multiplication of white blood cell. Okay, next. For the parameters that we have identified from this article, such as instability index, aliphatic index, grain average hydrophagy, gravity, molecular weight, and half-life. The first parameter is instability index. It is an estimation of the stability of the protein. When the value of the instability index is less than 40, the protein is said to be stable. However, if the value of instability index is more than 40, the protein is said to be unstable. Next is the aliphatic index. It is the relative volume occupied by aliphatic side chain. It may be regarded as the tools for the prediction of thermostability of the protein. The third one is the grain average hydrophagy. The gravity values will give the idea of the hydrophilic or hydrophobic nature of the protein. It gives the idea whether the protein is hydrophilic or hydrophobic. And the half-life is the time taken for the concentration of targeted protein to be reduced by 50%. Okay, next is the result of the parameters. For the instability index, as mentioned before, when the value of the instability index is higher than 40, the protein is said to be unstable. So the protein in this article, the instability index value is higher than 40, which means that the protein is highly unstable and reactive. For the aliphatic index, for this protein, it is highly aliphatic because it has the high value of aliphatic. So with the high value of aliphatic index, it suggests that the protein molecule to be thermodynamically unstable. For the half-life of this protein is low half-life. And grain average hydrophagy of this protein, it has the value of hydrophagy less than 0. All the leukemia protein investigated were found to be hydrophilic. Okay, all of these parameters have been identified by using ProtParam software. So next, I will pass to Sister Alia to continue with the software that were used in this article.
Okay, next I will explain about the software that were used in the journal. There were a total of 7 software that we have used. The first one is Accelerate's Discovery Studio, which used to do all the modeling and simulation of proteins. The second one is self-optimized prediction method with alignment tools, SOPMA, which to identify the secondary structure. The third one is XPCI ProSite tool, which used to identify the functional sites of protein. Next slide. So next is PSORT. It is used to determine the subcellular location of the proteins. Then we have PROTPARAM to identify the physiochemical parameters such as instability index, aliphatic index, molecular weight, and etc. Then we have PyMod, which to purify the protein collected. And lastly, we have Aceris Material Studio, which do the modeling and simulation of magnetic nanoparticles. Next. So this is the results from the journal. It has been found that this protein secondary structure is a random coil type, which is generally random coil exists in denatured and denaturing proteins. Then we have enthalpy values. From the graph, we can see that the enthalpy values for all the nanoparticles are found to be negative, which indicate them as an exothermic compound. This explains the thermodynamic stability of the proteins. Next, we have a binding energy. So for the binding energy, Fe3O4 nanoparticle have a maximum binding energy compared to Fe2O3 and FeO. And we found out that 1.1 nanometer size Fe3O4 has the highest binding energy with the protein, which the value is 2.49 times 10 to the power of 16 kilojoule per mole. Meanwhile, FeO show the least binding energy with the size of 0.6 nanometer, which is the lowest binding energy, 3.143 times 10 to the power of 8 kilojoule per mole. And lastly, we have the relationship between the size of nanoparticle and total energy. It is directly proportional. As the size of nanoparticle increase, the total energy also increase. Next. So the advantages using the MD simulation, there are three advantages, which is it can treat both ligand and protein in flexible way. It can predict the accurate binding energy, BE, and it can provide a detailed information about the proteins. So next, I will pass to Siti Zulaika for the conclusion.
Okay, so for the conclusion, from this article, we have found that leukemia protein was successfully being isolated. There were 3 nanoparticles that have been identified, such as iron 2 oxide, iron 3 oxide, and iron 2 3 oxide. So from this article, we have found that iron 2 3 oxide is the best nanoparticles for the interaction with leukemia proteins, because it has the highest binding energy compared to the other 2 nanoparticles. And for this particle, 1.1 nanometer size is found to be the most suitable for targeting and isolating leukemia protein. So that's all for the question 2. Next, I will pass for the question 4.
Thank you, Sister Zulaika. Now I will answer the question. I will answer the question 4, which is from Excel data. Next slide. First is the difference between number of movies and TV shows added to Netflix in 2020 and 2021. This is the pie chart that shows the number of movies and TV shows in year 2020 and 2021. Number of movies and TV shows in 2020 is 953, while in 2021, the number decreases to 592. So after subtracting 592 from 953, the difference between number of movies and TV shows added to Netflix in 2020 and 2021 is 361. Okay, next slide. Here is the number of movies that were added to Netflix from 1998 until 2018. After adding each movies from year 1998 to the year 2018, it's concluded that number of movies that were added to Netflix from 1998 to 2018 is 4,292. I will pass this presentation to Brother Zulhadi. Thank you.
Thank you for Brother Azim for his presentation. Now in my part, I will explain to you the difference between the number of movies and TV shows from UK in 2020 and 2021. The number of movies and TV shows from UK in 2020 are 44. It consists of 19 movies and 25 TV shows. Number of movie and TV shows from UK in 2021 are 22. It consists of 6 movies and 16 TV shows. The difference between the number of movies and TV shows from UK in 2020 and 2021 is 22. Next slide. Now we move on to the numbers of rating in Netflix. Rating of movies and TV shows with the highest number in Netflix is TV-MA, which is 3,207, while the rating of movies and TV shows with the lowest number in Netflix is NC-17 NUR, which is only 3 for both of them. That's all from us. Thank you for listening.